I'm John Zaiss. I'm a principal engineer working cloud native architecture at Mastercard. I came to Mastercard as a contractor to deliver one project, and it went well, and I decided to stay there, and that was over 20 years ago. One consistent thing about my roles has been I've always worked on emerging technology, and that's why I joined our effort to deliver Kubernetes at Mastercard 6 years ago. It's been an interesting experience learning a new technology, developing the solution, and at times educating our peers about cloud native apps, containerized microservices, so they can effectively help us on this journey. Before we dive into Kubernetes, a little bit about Mastercard. We're a technology company in the payments business. So our core payment network is switching electronic payments, covering authorization, clearing, and settling transactions for account holders like you and me, for the merchants we shop, the financial institutions that acquire the transactions, and for the financial institutions that issue our cards. We have a number of value-added services, cyber and intelligence, data and services, for example, all working together to enable digital payments. So let's move on to talk about Mastercard's journey to Kubernetes. Mastercard private cloud ecosystem doesn't have a Kubernetes platform. We wanted one, but why? Okay. We have a lot of use cases that don't fit well into our Cloud Foundry environment or are a good fit for public cloud offerings. So we began the journey to Kubernetes with something we've now branded as Mastercard Kubernetes Service, or MKS for short. Security is a concern. We have workloads that must stay in the private cloud. We want to take advantage of the increased scalability and reliability that Kubernetes brings. One of the highest value propositions we feel at Mastercard is the developer experience. What we want to do is enable developers to create innovative solutions where application teams are free from being tied to infrastructure deployments, planning for it, what kind of servers do I need, waiting for operating systems to be delivered, and they can focus on developing great software. The developer experience is something we want to refer to as a build once, deploy anywhere, which is key to our cloud platform, unified cloud platform approach. We have peer teams to the MKS team for each of the cloud platforms. Also, like many large organizations, one way we grow is by acquiring additional technology solutions. So MKS will set us up well to bring these new colleagues in, since many we find have already begun their journey to Kubernetes. So how do we get to this point, and where are we now? We started with a vendor-deployed solution that was from the same provider that built our Cloud Foundry platform. We made great progress. We learned a lot, built a great team, and we're ready to deliver, and then came to the point where cost started to be a factor, and we were challenged of, hey, why are you guys paying for free stuff? So we started the journey over again on trying to pull this off with open source. And again, we pulled together some great innovative solutions, and we actually did an initial release of the platform. Took longer than we wanted, took a lot of custom code. Platform provided value, but we're becoming experts in what we refer to as the low-value technical details. Most significant example of this is we were managing and securing and updating the VM operating system for the Kubernetes nodes, and we were not even really becoming efficient at it. All of which, required a lot of custom code, and it's kind of being low value of the whole Kubernetes ecosystem based on our limited capacity. So how did we get to the higher value of the platform? We needed to bring back a partner, and really, spoiler alert, I'm up here talking, so we found a great partner, right? We found our advanced partner to do this with us. We found with OCP, we can design a multi-cluster architecture that is highly repeatable, leveraging standard compute architecture. We'd like to bring in a very standardized compute that's predictable. Was putting this on a path to deliver the platform that's more cloud-like. By bringing in Red Hat and OCP, we can focus more on the expertise of creating awesome developer experience and delivering a platform to align with our peers in the public cloud to create a unified experience. And with Ansible and the OCP experience, fits well into what we call militant automation, where we let the machine manage the platform. So we structure our architecture with a triple redundancy mindset. We've standardized our hardware on 3 racks with identical hosts. This modular approach gives us a predictable unit of compute that we can easily manage the capacity, the rate of consumption, and timelines for replenishing this. Now, unlike the public cloud, we're not completely compute on demand, so we need to stay ahead of that in our planning. We deployed nodes in groups of 3 and an even distribution across the 3 zones of compute. This ensures that any workload that's running in an MKS cluster can survive the loss of a single zone or rack without interruption of service. Even the rescheduling wouldn't cause an impact. This predictable architecture sets us up well for where we can add another pod of compute, overloaded term, but a very distinct rack or set of racks and compute that we know what that consumption is and how far advanced we need to get to. Our architecture is really going to be aligned with public cloud offerings, ensuring that we have equivalent level of availability. It supports our build once, run anywhere offering, so developers can build applications and not worry about any differences between which cloud provider or whether it runs on premise or not. So to modularize our deployment using Ansible, we deploy distinct repositories that separate code and configuration. I mentioned militant automation. Our architecture facilitates the deployment and management of the pattern, enabling the machine, right, to autonomously define the infrastructure instructions with minimal input, meaning we can say we want to go to this environment, define the network, point us to the compute. Not only do we have distinct repositories, we know where our support teams are, and it could automatically build out all of the code it needs to configure the environment. We leverage multiple CD jobs to generate these input and construct the content, which get turned into the declarative manifests, which are subsequently used to execute the Ansible playbooks. We've developed something we call a config file generator, where we can declare the name of the environment, and it builds all of the documents that we need to bootstrap the environment, and the machine configured files publishes them all to bootstrap a new MKS environment in a matter of a few hours. Security is top of mind at Mastercard, as you can imagine. We work closely with our security partners. And I've got a quote here from our security engineering team that we've worked with ever since we brought Kubernetes in, and especially with Red Hat. And outside of the hundreds of security defaults that Red Hat OCP gives us out of the box, it enables Mastercard to enforce OK gatekeeper policies from a central location, along with performing the continuous compliance scans of the cluster itself with the ACS compliance operator. To assure that we have a assurance on each running platform. That's directly from our Director of Security Engineering. And how do we do this? Alongside the repos we use to configure the environment, we generate separate repositories for admission control, network policy, and machine sets, where we know we're building from a standard pattern that's been approved by security. Any changes of that require us to also get the approval of security or networking, depending on where that lies. Yeah, that's what I've got. Thanks for listening. You can join us later in the week for a deep dive on MKS. Thank you for your time, and enjoy the session and the rest of the week.